Okay, good evening everyone. So now let us discuss our next problem related to exam Coal India Limited. Yeah, hi Shashank. But before discussing any example, do you have any doubt related to yesterday class? So you can ask to me. Okay, hi Kayur, Yogesh, hi. So now we are going to discuss our next example is this one. Read that example carefully and tell me. Good evening. Nice to see you after a long time. Thank you, Kulkarni. So here we have a switch module in which one BJT and one diode is present. Good evening, everyone. In that case, we have to draw VI characteristics of the device or switch module. And the options are ideal. That means VI characteristics of the switch module are given in ideal form. So that's why all characteristics are in piecewise linear. In that case, we have to determine right option. What is the difference between harmonics and noise? Anas Khan. Okay. Anas, due to harmonics noise introduced, due to harmonics power factor decreases, due to harmonics efficiency reduces. So when harmonics present or any interrupted signal present, then noise will introduce. So noise born due to harmonic components. For example, when we operate our load by inverter in domestic field, in our home, house, whatever, then due to inverter conversion, DC to AC, some harmonics are present at the output of the inverter. Due to that harmonic, fan, tube light, inductive load produce some sound. Okay, so this series available for the mechanical also. Nani Charan, I don't have any idea about mechanical. You can ask that type of things directly through Gradeup. Option C is right, reply sir. Okay, so that is the thing, Charan. So now option C is right. Now see properly, and in the same question, I would like to ask you what will be the ideal characteristics of diode and separate ideal characteristic of BJT. Yes, anyone? So here we know that the VI characteristics of ideal diode and ideal BJT will be, diode is unidirectional device because it can pass current from anode to cathode. Cathode to anode current can flow, but that is almost negligible and called reverse current. Okay, so that current is not useful, so no need to consider in ideal case. So that's why diode will pass current only in positive direction. So we are drawing here, this is our plus I. That is the VI characteristic of diode. And when diode is, this is the, wait a moment, we are not taking I here, we want to take I in vertical direction. So this is our I, okay. And here we want to plot current I positive, because diode, you know, unidirectional device. Hi, after long time, thank you Raj. Okay, good evening Prathavan. Now see, when diode is off, it can block negative voltage only. You know very well. If we apply positive voltage across the diode, suppose here we apply positive, here negative, an ideal diode will conduct definitely. Nobody can stop the conduction of diode when this anode voltage is just greater than this cathode voltage. Now if we apply negative voltage across it, it will be off and it will block whatever voltage we will apply across diode. So now this is that one. So diode can block negative voltage. On that behalf, we can say it is unipolar device with respect to blocking voltage. Please mind it, okay? And with respect to positive current passing, it is called unidirectional, because current flows only anode to cathode. So this is the VI characteristics of diode, where this is minus V, that one is plus I. In the same way, what about BJT? BJT, we know that, my dear friend, BJT VI characteristic is something like this. It appears only in first quadrant. Hi, Yaswant. So here BJT VI characteristic appears only in first quadrant. Due to that thing, ideal BJT, when it will work as a switch, it will pass positive current and will block positive voltage only. So here positive voltage and positive current, this is the VI characteristics of BJT, and that one is the VI characteristics of diode. Now these two characteristics we have to merge. so that we can select right option. Now see, that is the series combination of switch. So one thing you should clear, my dear friend, that is nothing but when BJT on, guaranteed diode on, and vice versa is also true. Out of these two devices, if one is off, guaranteed another one will also be off. So either both devices can simultaneously turn on or they will be simultaneously turn off. We don't have any third choice. It is clear to all, please. So dear friend, here in this circuit configuration, if we have BJT in such fashion with diode, it is called anti-series configuration. Please mind it. Anti-series configuration. Now in anti-series configuration, 16 batch ACE Academy Bhopal, Gaurav Sharma. Okay, yeah, I taught there, and I didn't recognize to you by name, but if we will meet, definitely I can recognize you. Sir, if another diode is connected in parallel to the BJT, then characteristics will remain same or different. It will change, my dear friend. Okay, please again tell. Okay, so dear, this is the like anti-series configuration. Why it is called anti-series configuration? Because when BJT is on, that is not guarantee diode on, or when diode is on, that is not guarantee BJT on. But roughly we can say when BJT on, guaranteed our diode is also on. But if we apply any positive voltage across that configuration, it is not necessary that both devices should be on. That depends upon the whether we are providing triggering pulse to that BJT or not. If we provide, then BJT on, otherwise not. Okay, so this is the anti-series connection. Now my dear friend, see, सबको ध्यान से हर एक पॉइंट को ध्यान से समझना. Hi पवन चल्ला, good evening. So listen very carefully, dear. Whatever voltage we apply across that switch module, okay, that voltage will block by either BJT or diode or by both. Okay, thank you Dilip. So this is the thing. Now dear, एक ही एग्जाम्पल में हम लोग बहुत सारी बातें सीखेंगे so that you can score good marks in your exam. Now this is the series configuration. If we apply positive voltage here, my dear friend, in that fashion, and we are not providing base triggering, that means BJT is off and diode is on. But that thing is never possible, I told you, because diode can turn on only when BJT is also on. So if we are not providing base current to this BJT, BJT is off. In the same way, when BJT off, diode is also off. So both devices are off. But that positive voltage will block by only BJT, will not block by this diode. Why? I told you, my dear friend, diode cannot block positive voltage. Diode can block only negative voltage. Yeah, good evening everyone. What is the difference between cascading and cascading? Cascading and cascading. Dilip, cascade means your series connection and you are writing same spelling. I am a bit confused. Okay, do you have any example so that we can discuss on that topic? Okay, so this is the thing, dear. Suppose, dear, here we apply plus minus 100 volt and both devices are off, then this 100 volt will block by only BJT, not by diode. In the same way, if we apply minus plus voltage, then suppose here 100 volt, then this 100 volt will block by diode, not by BJT. So this is the advantage of that switch configuration. What is the advantage? If we apply positive voltage, will block by BJT. If we apply negative voltage, will block by diode. Individually, they don't have that characteristics. Because my dear friend, individually if we see, diode can block only negative, BJT can block only positive, but when both are connected in cascaded nature, they can block both voltage, positive as well as negative. So this is the beauty of that switch configuration. But somebody can ask to me, sir, then SCR is good device in comparison to this, because SCR single device can block both voltage, positive as well as negative. But dear friend, SCR rating, SCR frequency is somewhat different. Sometimes we require that type of switch configuration also. due to some reason. We can control switching losses. We can control conduction losses, as well as we can operate our system at high frequency. So there are a lot of reason to use that type of switch module to design chopper, inverter, like different type of devices or converter we can say. So sometimes that configuration is much better than SCR, and sometimes SCR is better. When SCR will be better? When high voltage or high current we want to sustain. In that case, SCR is best choice. But for low switching losses, low conduction losses, high frequency, we should select that switch configuration. Okay? Sir, please suggest Power Tonics book for CIL, and which book good practice? Gaurav Sharma, I think PS Bimra will be good book for you for the CIL exam. Don't refer any other book. Success Forever, sir, SSC previous year question book is good for CIL. SSC previous year question is okay, but you have to follow some reference books also. Okay? Yeah, Gaurav Sharma, is previous year get 1 marks and ESC question are sufficient? Yeah, Gaurav, definitely you can handle, or everyone can handle ES previous year example as well as low level gate examples, some IAS objective examples. Okay, previous year, I think before 2010 or 11. Nowadays they are not conducting electrical prelims. Okay, but before 2011 you can get. So that type of question, if possible, you should arrange and solve all those type of question, so that you can understand all the concept related to your subjects. Cascading, explain please, sir. Yeah, Dilip, tell me what is in which field you want to ask cascading. Like in electrical circuit, in like power system, cascading means whenever we want to connect two systems in series, that is called cascading. Okay? Cascading and cascading. Dilip, I am a bit confused. I am not like getting your question well. So do you have any example, like for example, sir, in that example, what is the meaning of cascade? Or in this example, what is the meaning of cascade? Okay. So here, suppose we have two networks in that fashion, and we can connect these two networks by cascade fashion. That is the thing. But in signal system, sometimes it is different thing. Okay. So Vipro Das, good evening, electronics, sir. Electronics means, yeah, cascading is this one only, Dilip. Okay, I have applied electrical department AE. Which book is best for professor? Yeah, PS Bimra is good. Okay. So this is the thing. Otherwise, do one thing, Dilip. If you have any doubt related to electronics or analog circuit in cascading fashion, so you should ask to any analog faculty. Maybe that faculty will guide you in well way. Okay. According to me, in my subject in circuit theory as well as in power tonics, cascading means just we have to connect two different bodies in that nature, so that current can pass in the same way. Okay. Yeah. Which book for machine? Machine you can follow like Aspirants Ocean. Okay. And Aspirants Ocean is okay for you. But if high class, if a good book you want to follow, then PS Bimra will be best. Okay. Satyam Kumar Ravi, cascoding. Cascoding, I don't know, yaar Dilip. Cascoding, I don't know. Okay. Thank you. So this is the thing, my dear friend. Now see. So in that particular case, what is the advantage of that configuration? I told you. Now according to this, we have discussed when BJT on, our diode is on, so that device will be unidirectional. And when BJT is off, diode will also off. If we apply positive voltage, then BJT will block. If we apply negative voltage, then diode will block. Due to that reason, that device will be unidirectional and bipolar, or we can say it can block voltage of either polarity. That thing in short, in technical word, is called bipolar. Here bipolar means, or here bipolar doesn't mean like holes or electrons, whatever, please mind it. Okay. So here on that base, we can draw the VI characteristic of this device will be plus I, plus V and minus V. Okay. So that thing is clear to all, I think. So this is the VI characteristics of. So now select the right option. Right option is nothing but option C. It is clear to all? It means VK meta objective is good. Yeah, definitely VK meta is also good. Okay. Hi, ready? This is a thing, dear. Now, my dear friend, we are going to discuss next example. And in that example, you have to again tell VI characteristic of device. In between, you can ask any doubt if you have, my dear friend, so that we can discuss your doubt also as well as this problem. So read that problem carefully. I am giving you some space to read this problem. There is one MOSFET and one anti-parallel diode. Now, so it's acts similar to SCR characteristics. Yeah, Kumdini, it will be similar to SCR characteristics. Why it will be similar to SCR characteristics? Because SCR can block voltage of either polarity and can pass current in single direction. But everyone, there is a lot of difference in between SCR and diode and BJT series connection. Diode and BJT series connection cannot sustain high voltage, but SCR can sustain high voltage. Okay, so here everyone are replying option B is right. Okay, anyone else? Please tell me fast. B. Good. Gate की अच्छी preparation कर रखी boss. So B is correct. Yeah, Dilip, definitely B is correct. Now, why B is correct? Can you tell me? Why B is correct? Can you tell me? What is the main reason behind this option? Tell me, anyone. Why option B is correct? What is the main reason? Yeah, success forever is replied C. Now listen to me carefully, यार. अच्छा सा थोड़ा समझते हैं. Why B option is right? What is the main reason why you are replying option B is right? Sir, which are the topics need to cover in power electronics? We have to cover all topics. For example, basics, GTO, SCR, etc. Few concept of chopper, few concept of rectifier, few concept of MOS, like inverter, few concept of AC voltage regulator. They are free to ask from any topic. Okay, so we have to cover bit idea of every topic. Diode conduct reverse parallel diode, this is a thing. Now see, dear, listen to me carefully. Listen to me carefully. If I am removing this diode, listen to me carefully. I am removing this diode, that diode is not present, and we are using that MOSFET in that fashion. Okay, same symbol, no change, in that fashion. Then what will be the VI characteristics? Please listen to me carefully. I am not showing, or I don't want to show you this diode. Okay, let us assume that diode is absent. Okay, let us assume that diode is absent. Now tell me what will be the VI characteristics. Please, somebody. Diode block current in reverse bias and diode anti-parallel reverse conduction something. Yes, anyone please. This diode is not present, then what will be the VI characteristics? Yes, everyone. Like from option, can you tell me? I am providing last E option also for you. When diode is not present, for that I am going to provide option E in that fashion. Wait a minute. E and F, I am providing two options. So minus V plus I and plus I plus V. Now tell me. So now you have 6 options. When diode is not present, which option can we write out of these 6 options? Option A, same as B without I. Okay, like BJT, Okay. Any other boy or girl? Anyone? F. Yeah, listen to me carefully. That is the thing, dear. Please listen to me carefully. MOSFET has anti-parallel diode inherently. Anti-parallel diode is present inside the MOSFET. Inherently means inside the MOSFET. It means no need to show that diode. If somebody is not showing this diode, please mind it. If nobody is showing this diode, in that case, again, option B is right. Please mind it. Please mind it. MOSFET has inherently body diode. So there is no difference if that diode is given or not given. In both cases, answer will be same. Just keep in mind. In both cases, answer will be same. And due to body diode, sometimes they can represent that body diode externally, sometimes they will not show. So please mind it, in any case, our characteristics of that MOSFET will not change, in power electronics especially. Now my dear friend, see, that MOSFET inherently is a bidirectional and unipolar. Unipolar means not holes or electrons. Unipolar means voltage wise. Okay, voltage wise. So it will be bidirectional and unipolar voltage wise. So bidirectional means current positive as well as negative, and MOSFET can block positive voltage. So option B is right. Now this option C or D, whatever is wrong, these options are also wrong, and that one also wrong. Here positive voltage, negative voltage, positive current will be the characteristic of SCR, my dear friend, because positive voltage, negative voltage and positive current. Here my dear friend, positive current and negative voltage, that type of device we can design, but directly we don't have a device such that can provide like plus I, minus I and negative V. Okay, yes. So book for non-gate tech government exam electrical, Ranjan Kumar, sorry beta ji, I don't have any idea. MOSFET is a voltage control device. Yeah, definitely Ali, MOSFET is voltage control device. IGBT is voltage control device. Dilip Yadav, nice to watch you lecture sir, and this time I am busy, so bye sir. Okay, thank you Dilip. So E and F not possible all time. Yeah, definitely. MOSFET voltage control device, IGBT voltage control device, BJT, SCR, GTO, TIC, etc. are current control device. So सिर्फ आपको इतना ध्यान रखना है my dear friend, when we trigger our device by current, those type devices will be current controlled. When we want to trigger our device by voltage, those type of devices will be voltage controlled. Okay, do discuss gate source voltage. Okay, Saturn, I think this type of question or that type of question will not be beneficial for CIL exam. Okay, so JB Gupta, yes, GTO के बारे में, GTO, everyone listen to me carefully. GTO is a, okay, it is a good question. So we are going to discuss about GTO something. My dear friend, GTO is similar to SCR, but SCR is, I told you, semi-controlled. Okay, but my dear friend, GTO is control device. Okay, controlled device. Why GTO is control device? Because we can turn on GTO by positive gate pulse and we can turn off GTO by negative gate pulse. But unfortunately, due to this changing phenomena, GTO positive voltage blocking capacity is very low in comparison to SCR. So if SCR can block high voltage in terms of 5 kV, 6 kV or 7 kV, we cannot design GTO with such type of voltage range. So this is the negative thing about the GTO. Otherwise, GTO is similar to SCR. Characteristics wise, GTO will pass positive current similar to SCR, will block negative voltage similar to SCR, but this positive voltage will be very low. Please mind it, this positive voltage will be very low. Okay, and my dear friend, for SCR, the VI characteristic will be positive current similar to GTO. Positive voltage and negative voltage are almost equal. So in SCR, forward blocking voltage, reverse blocking voltage will be equal, whereas in GTO, positive voltage in comparison to reverse blocking voltage will be very low. Okay, yeah, power consumption in very complex method prefer Thevenin or Norton superposition or Kirchhoff. Just wait a moment, dear Anash. Now everyone listen to me carefully. Somebody is asking, when power consumption is very complex, which method we prefer, Thevenin, Norton superposition or Kirchhoff law? Listen to me carefully, dear. If your circuit has different frequency of sources, if your circuit has different frequency of sources, means a circuit which is excited by like 50 hertz. Okay, for example, I am going to take here, we have some load, my dear friend, and that load has R, L, C, all elements, and that load is going to excited by like supply voltage 50 volt and 80 sine omega t something. Okay, so there is some frequency and it is independent upon frequency. The frequency of this signal will be 0 because pure DC. That type of signal or that type of circuit, always we have to like follow, or always we have to solve by superposition theorem, because superposition is very, very important when our circuit is going to operate by different frequencies simultaneously, by different frequencies simultaneously. We don't have any second choice to handle that type of circuit. Okay, now dear, if circuit is very complex and operated by single frequency only, please mind it, operated by single frequency only, then to reduce the size of the network or circuit, you can follow Thevenin theorem, Norton theorem, because that type of theorems will be suitable to reduce the size of the circuit, as well as mathematical analysis will be easy. Okay, so this is the thing. Just wait a moment. And Kirchhoff law, KCL, KBL, Ohm's law, wherever you want you can apply. So that is not typical question. Symbol for GTO, sir, symbol for GTO, my dear friend, will be something like this. This is the symbol of SCR. Okay, this is the symbol of SCR. Now my dear friend, this is the also symbol of SCR. That one also the symbol of SCR. And what about GTO? GTO symbol will be something like this, current in both direction. If current is given in both direction, then that device will be GTO. Okay dear, sir, for network theory, which book will you suggest? Ambuk Pati something. Dear, for circuit theory, for the CIL exam, you can follow Aspirants, William Haight, okay, some basics books only. And prefer to solve ES objective question of circuit theory as well. Gate current किसमें ज़्यादा होता है sir, SCR और GTO? Dear Shivam, with respect to gate current, actually gate current is not a constant phenomena about the SCR or GTO or trike or any power tonic devices. Please mind it. Gate current will decide by the device rating. Device rating. Yeah, hate. So device rating. So see, whenever our load or device are connected in some fashion, the gate current magnitude will decide by the switching loss of the controlling circuit. So we have to provide gate current in such a range so that our losses in the controlling circuit should not exceed above the rated value. If switching losses are higher than the rated, then our device may get damaged. So always we should provide controlled gate current to the SCR or GTO. But there is no such type of question. So you can say GTO gate current is high or SCR gate current is low. Please mind it. That type of stupid question will not be available anywhere. Okay. Now see, it can pass current in both direction depending upon its rating. Ranjan, which E we can expect most number of question in CIL? Mainly Ranjan, they will ask question from the core, for example power tonics, machine and power system. Now it can pass current in both direction. Which device beta ji? Harish, I'm not getting. If you are talking about SCR, so SCR for SCR it will be wrong. Sir, stick to CIL preparation, please give number of question. Sir, you explain very well. Thank you, Kritika. So this is the thing. Now, my dear friend, for that particular example, our option is B in any case. Now we are going to discuss next example. Find the current through 5 ohm resistance. Read this example carefully and tell me the final answer. And please try to solve this question. And somebody is asking to me, sir, thyristor is A stable or bi-stable? Jitendra Singh, please elaborate your question. What is the meaning of A stable and bi-stable? Okay, And please try to handle this question. Meanwhile, I am going to explain what is the meaning of bistable, whatever I'm getting. I'm not sure, Jitendra, whether I'm getting your question in proper way or not, but by emotions, I'm going to reply. Sir, approximate cutoff for CIL. Mistry, we will discuss that type of things sometime later. Sir, you explained very well. Thank you. Okay. So, beta ji, see, what is the VI characteristic of SCR? VI characteristic of SCR is something like this. In that region, my dear friend, in this case here, that is called switching period. In switching period, in that interval, we have R less than 0. If R less than 0 means unstable mode, okay? And here, my dear friend, we have R greater than 0. Why R greater than 0? Because slope is positive. Here slope is negative. Slope negative, that's why R negative. When R positive, it will be stable. And here, my dear friend, it is called forward blocking mode. In forward blocking mode, again R is positive. So it is called stable. Okay. So in SCR VI characteristics, we have one stable that region, another stable this region. On that behalf, we can say it is bistable. Okay, this is the thing. So, sir, by solving previous year EESC thyristor, yeah, this is the thing, Jitendra. Okay, so you can say on that base, if your question is according to that analysis, you can say it is bistable and one region is unstable. That is the thing. Okay, so leave it. Now, answer is 0, 0, 0, 0, 0. Okay, everyone. So, I think obviously you will be right or you should be right. So this is a 5 ampere, this is the 2 ampere, and we have to determine current through this 5 ohm. Okay. Sir, please suggest any online sources for the CIL general awareness. Okay, Ram, definitely tomorrow I will suggest you. Okay, and I will keep your point in my mind, and definitely I will suggest you. Okay, I will not forget that thing. Sir, GTO में higher latching current or holding current होता है? Yes, Shivam Rana, in GTO, holding current is very, very high. Around 30 to 40% of anode current, but in SCR holding current is around 1% of the anode current. So that is the basic difference in between GTO and SCR. Okay, now dear, before handling any circuit, we should take a reference point, as I told you yesterday class also. So just take a reference point here. Okay, now dear, if here 5 ampere current is flowing, here we can assume some I. So in that wire, how much current? 5 minus I. Okay, dear. Now, how much here current, my dear friend? I. This is the 2 ampere. Both are adding. So, current in this wire is I plus 2. As I told you, my dear friend, never apply KVL in the mesh or loop, whatever closed by a current source. So, ignore that type of mesh or loop if possible. So, now we are going to apply KVL, my dear friend, in outer loop. Now somebody tell me equation. Yes, so current flows higher to lower, current flows higher to lower, current flows higher to lower. So plus 5 minus I into 2 plus, my dear friend, in that way. So okay, so this is the direction we are going to consider. So I'm going to write here minus sign. Okay, this is the direction. So minus 5 minus I into 2, this thing. Then my dear friend, 10 into I, second drop, 10 into I. And this last drop, 5 into I plus 2 is equal to 0. Yeah, tell me somebody what will be the answer. So, minus 10. Okay, I'm going to write by different color here. Minus 10 and plus 2I and plus 10I and plus 5I and plus 10. Is equal to 0. So 10 and 10 cancel. Obviously, all of you are right. I think I is equal to 0 ampere. That is the thing. 2 ampere. Yogesh, just see this equation. If I am not wrong, so minus 2 into 5, so minus 10, minus and minus plus 2I, plus 10I, plus 5I, and 5 into 2 plus 10. And minus 10 plus 10 are cancel. So we don't have any constant value. So answer will be, I think, 0. Okay, please see. Want superposition be simple approach, sir. Please, everyone minded, never apply superposition superposition will give complex result, okay, or complex calculation. We have to handle a single source at a time only, independent source. So that is the thing. So if somebody pressurize you to apply superposition, then only apply, okay. So this is the thing. Now my dear friend, it is clear to all, I think. We are going to know through resistance 2 ohm. Okay, so yeah, here maybe 5 ampere. Yeah, I0, so that current will be 5 ampere. Yeah, sir, can't we use source transformation? Yeah, dear, we can use source transformation as well as, but please mind it, at the time of applying source transformation theorem, never change the location of load. Never change the location of load, please mind it. What I would like to say, I want to explain by an example. See here. Suppose beta ji, we have one voltage source in that fashion and one resistance here, another resistance somewhere here. Okay, it is R, that one is suppose 1 ohm, that one is suppose my dear friend 4 ohm, that one is 10 volt. And we want to calculate power of this resistance 1 ohm. So P of 1 ohm we want to determine by superposition theorem. By superposition theorem. Dear friend, we are going to convert that voltage source and this resistance into current source. So what will be the value of current source? 10 by 1, only that portion. So this current is 10 ampere in that direction. This R 1 ohm will come in parallel and that rest resistance 4 ohm will be same location. Now dear, here how much current will flow? 10 and 1 4, so 2 ampere. Now what will be the power loss in this resistance? Is nothing but 2 square into 1, how much? 4 watt. Now dear, for this circuit, what will be the current in this wire? That current by current division rule we can calculate. So 10 into this current, opposite resistance 4 divided by 1 plus 4, 5. So how much is 8 ampere. Now what will be the power loss? In 1 ohm, when we apply source transformation theorem, 8 square into 1, 64 watt. See, that is the difference. So never apply superposition theorem directly. First try to understand the example and then apply that type of theorem with patience and full concentration. You are not supposed to change your location of load. Here I assume that is our load or whatever element in which we want to calculate power. And unfortunately I have changed the location of this 1 ohm. So that's why answer is not coming same. So please don't do that type of silly mistakes. Okay? Yeah, everyone. I think it is clear. So any other doubt, please let me know, everyone. Now my dear friend, we are going to discuss next example is this one. Determine the current I. Yes, everyone. Sir, through 5 ohm resistance current I ask, so I write answer is 2 ampere. Okay, no issue my dear friend. Okay, no issue. Answer sometimes doesn't matter. You are getting like your concept or whatever we are discussing, you are getting properly or not, that is the thing. Because yeah, you know, I know in 1 hour we cannot do calculation type of things. We can understand the concept in well way. So try to understand the concept first. Okay, by solving ESC previous year paper can be able to get CIL. Yes, beta ji, definitely by solving ESC paper, IAS, objective type question and any previous year exam related to BARC, ISRO, GATE, like low level problem. Okay, that type of problem you should handle to crack your CIL exam. Okay, so this is the thing. Yes, so now in that question, please somebody tell me what will be the value of current I. Yes, everyone, what will be the value of current I? Yeah, 60 by 17. Okay, so thank you. Yes, everyone, tell me. I'm giving some space. Just read the question properly and tell me the final value. And try to solve that type of question within 30 seconds, 20 seconds only. Okay, because not too much tough. Power transistor में secondary breakdown explain. Okay, so you guys just try to handle that problem. Again, I am going to discuss one doubt from Shivam Rana. My dear friend, BJT has negative temperature coefficient. We don't have like too much time, so I can't like explain that type of things in detail, but I'm giving to you some idea, my dear friend. BJT has negative temperature coefficient. What is the meaning of negative temperature coefficient? You know well, okay, or you should know well. Now negative temperature coefficient introduces secondary breakdown problem in the BJT. So for the secondary breakdown problem in BJT, responsible things is nothing but negative temperature coefficient, and negative temperature coefficient comes due to the configuration or designing of BJT. Okay, yeah, 60/6, 4/3, 60/7. Okay, so we have a different answer. So again we are going to handle that question. Now my dear friend, we have to calculate this current I. Okay, so that is I, this is 4. So here we can assume, my dear friend, 4 minus I. It is clear? So that is entering 4 ampere, I is leaving. So this current we can assume 4 minus I. Now dear, see, this is the current source. So ignore that current source first and apply KVL in outer loop. Okay, now somebody tell me what will be the KVL equation? Now see, this current is flowing in that direction. So plus minus, now I'm going to write here KVL equation, minus 3 into 4 minus I. Minus 3 into 4 minus I plus, my dear friend, 2 into I and minus 4V3 is equal to 0. How many number of elements are present in this circuit? 1, 2, 3. So in our equation only we required 3 drops. So this is the equation. Again, see whether polarities are right or not. So minus 3 into this is done, plus 2 into that done, and this polarity is minus, so minus 4V3 is this. Now my dear friend, we have two variables, V3 and I. To handle that circuit we require one more equation. That equation we can write from this element by Ohm's law. So V3 is nothing but 3 into that. So V3 is equal to 4 minus I into 3 is okay. Now with the help of these two equations we can handle or we can find out the value of I. Yes, anyone please tell me. So I'm going to write here, my dear friend, minus 12 and plus 3I plus 2I minus 4, and V3 is 3 into 4 minus I, 3 into 4 minus I is equal to 0. Yes, anyone please tell me what will be the exact answer of I. So I is 12 and 3. So minus 12 plus 5I, this 3I and this, and minus 4 and 4 minus 3I. So that value will be, beta ji, minus 48 and plus 12I. I think I'm not sure whether I'm doing well or not. So just check it, minus 48 and plus 12I. So 12 and ये 17I is equal to 12 पंचे 60, ये हो गया 60. So I think I is equal to, my dear friend, 60/17 is our final answer. Check it whether it is right or not. 60/17, yeah, that is the answer I think, my dear friend. So just see. Okay, so okay, no issue, my dear friend, if answer your is 60/13 or 60/17, whatever, just check the calculation properly. But concept wise, see, I'm never considering current source in our mesh or like loop analysis. You should consider your sir, it's very lengthy question. These type of question can come. Yeah, definitely, beta ji, that type of question they can ask. It is not lengthy. See, we are using single equation only. Okay, so please mind it. Now, my dear friend, I am going to ask same question, but this time, okay, wait a moment. This time, that current source is in that way. Okay, so we have one short terminals across that current source. Now tell me the value of I. Everyone, listen to me carefully. Can be this solve using node analysis? Yeah, definitely, Basar. We can solve that type of question by KCL, by KBL, by super mesh, by super node, by voltage division, by current division, whatever you want you can apply. You are free to apply anything. but you have to see which method will give answer in minimum step. That is the most important thing. Okay, thank you, Krishna. Now see, so dear friend, this is the thing. Now my dear friend, in that example, second example, this current source has some short wire. In that case, you have to tell me the value of I. Everyone please reply fast. The value of current I. The value of current I. Yes, everyone, I am observing your answers also. When this current source 4 ampere is got shorted, in that case, tell me the value of current I. So yes, 0 ampere, please discuss with node analysis. Okay, sure, I will discuss 0 ampere, 0 ampere, everyone are saying 0 ampere. Sir, I am not getting. Okay, Ali, which thing you are not getting? Just tell me. So this is the 4 ampere current source is. Please mind it, beta ji. All of you are absolutely right. See, this 4 ampere current will flow in that fashion only. And this 4 ampere current will not excite any element of the circuit. Okay, so this element will not excite by that current source. Please mind it, my dear friend. When any system, circuit or network is going to excite by only dependent sources, that system should never be responsible for any delivering power or absorbing power. In that case, our current or voltage of all elements will always be zero. So to excite our circuit or network, always at least we require one independent source. That is the thing. Okay. Yeah. So no active source in the circuit since current is short circuited. Definitely, beta ji. Okay, good. Everyone nice. So this is the thing. In that case, our current I will be 0 ampere. Okay. Please mind it, beta. To excite any circuit or network, at least we require one independent source. Either current source or voltage source. If independent current source or voltage source is not present, then our circuit will never excite and all components will be zero. What are the dependent source in real life, sir? Okay. Sir, please discuss Powell Tonics question. Just give me a few seconds, beta, so that I can discuss dependent source. Please mind it, everyone. Listen to me carefully fast. Dependent sources available only in electronic circuit. BJT, op-amp, diode, MOSFET, IGBT, those type devices will work as a dependent source. But in electrical core, we don't have any dependent source. Power system, dependent sources unavailable. Electrical machine, dependent sources unavailable. Please mind it, dependent sources are the part of analog circuit or electronic devices. They are very useful to control the values of voltage and current. So what is the main significance of dependent sources? They are nothing but kind of BJT, MOSFET, IGBT, and they are capable to control current and voltage magnitude as our requirement. Okay, please discuss with node analysis previous example. Okay dear, just give me few seconds. Chopper and inverter basis. Just wait a moment, my dear friend. We should discuss previous example, that one by node analysis. Okay, see my dear friend, here take ground. With respect to ground, you can assume, just wait, you can assume here some voltage V, there is some drop, so we can assume beta ji here V2. Now what will be the KCL equation for this node? Let this node is 1, this node is 2. I'm going to write here Kcl equation for this circuit, and for that circuit, yeah, somebody tell me what will be the Kcl equation. Just wait. So here, my dear friend, what will be the Kcl equation? Let this V1 is the highest voltage. So V1 by 2, this current is entering. So minus 5 plus V1 minus V2 by 2, V1 minus V2 by 2, sorry, V1 minus V2 by 10. This resistance is 10. So V1 minus V2 by 10 is equal to 0. Second equation for this node 2. So this is node 1, that is node 2. So for node 2, now we have to assume V2 is the highest voltage. So V2 minus V1 by 10. Now this current is going to enter. So minus 2 and plus V2 by 5 plus V2 by 5 is equal to 0. My dear friend, these two equations you have to handle so that you can find out V1 as well as V2. So after that, by Ohm's law or by potential difference, you can calculate whatever you want. Okay. पावर डायोड में 3 लेयर क्यों होती हैं? शिवम राणा, for that type of question we require some time. Okay. To block high voltage, we have to introduce extra layer, that is nothing but N plus layer. Okay, so what is the main purpose of N plus layer in power diode? Is nothing but to sustain high voltage. Just keep in mind. So this is the thing. Now my dear friend, we are going to discuss our next example is this one. First read this example carefully and tell me the final answer. No active source in the, okay, done. So match list first and second whatever, my dear friend, power devices and property, and the select correct answer using code given below list. Thyristor, MOSFET, IGBT, BJT. Just read carefully. Shashank, we will discuss definitely tomorrow chopper problem, okay? But today we have to wind up that class with some few more examples of power electronics, okay? Now see, so my dear friend, no need to handle that question for like few minutes, 1 to 2 minutes. Just forget about the question. Listen to me carefully. आराम से समझना बेटा. BJT, listen to me carefully. BJT provide, एक एक शब्द को ध्यान से सुनना. BJT provide, don't reply to me, please listen to me carefully. Whatever I am going to deliver, just listen those things. BJT provides minimum conduction loss in comparison to any other power electronic device. BJT provides minimum conduction loss in comparison to any other power electronics device, and MOSFET provides minimum switching loss in comparison to any other device. IGBT is a device which provide conduction loss higher than BJT but lower than MOSFET, and IGBT provides switching loss higher than MOSFET and lower than BJT. Sorry, IGBT provides higher switching loss in comparison to BJT. Wait a moment. See, MOSFET provides lowest switching loss in comparison to any other. First thing. BJT provides lowest conduction loss in comparison to any other power electronic device. Now my dear friend, IGBT is the modified version of BJT and MOSFET. IGBT controlling circuit will decide by the MOSFET, and IGBT operating circuit will decide by the BJT. Now see, IGBT conduction loss higher than BJT and lower than MOSFET. Why? BJT provides lowest conduction loss, and IGBT is the modified version of BJT. Okay, next thing, MOSFET provides lowest switching loss. So IGBT switching loss higher than MOSFET. okay, and lower than BJT. This is the thing. So that thing you have to keep in mind. Now again, most important thing, my dear friend, MOSFET operates at highest frequency. Still, okay, up to this time MOSFET operates, okay, wait a minute, listen to me carefully and just make some notes. IGBT, make some notes. BJT provides lowest conduction loss, done. Okay, BJT provides lowest conduction loss, done. MOSFET provides lowest switching loss in comparison to any other, done. IGBT, modified version of BJT and MOSFET. IGBT conduction loss higher than BJT but lower than MOSFET, is done. IGBT switching loss higher than BJT, okay, sorry, IGBT switching loss higher than MOSFET and lower than BJT, done. This is the thing. आपको सिर्फ क्या ध्यान रखना है, BJT सबसे कम कंडक्शन लॉस देता है, MOSFET सबसे कम स्विचिंग लॉस देता है, इन्हीं दोनों के मॉडिफाई वर्जन से IGBT बनता है. तो IGBT में कंडक्शन लॉस, IGBT में कंडक्शन लॉस BJT से क्या होगा, ज्यादा होगा, और IGBT में कंडक्शन लॉस MOSFET से क्या होगा, कम होगा. अब स्विचिंग पे आओ, IGBT में स्विचिंग लॉस MOSFET से क्या होगा, ज्यादा होगा, बट BJT से क्या होगा, कम होगा. दिस इज द थिंग. ओके, नाउ सी माय डियर फ्रेंड, MOSFET operates at highest frequency. MOSFET operates at highest frequency. BJT, IGBT, SCR operates moderate frequency. But still, highest frequency of MOSFET, then you can, if you want to arrange, then highest frequency MOSFET, then IGBT, then rest devices. So frequencies wise, we should select MOSFET and IGBT. Okay? Yeah, thank you everyone. This is the thing. So now on that behalf, you have to like follow that question. So now my dear friends, see, I told you just before few minutes ago, thyristor, leave it, BJT introduced secondary breakdown problem. So for D, first one is right. Now second thing, my dear friend, thyristor, see, large on state drop, hold it, small on state drop, hold it, slow device, hold it. We will finalize because here comparison is going on. So first we have to find out a small on state drop. Which device will provide a small on state drop? On state drop means conduction loss, and conduction loss lowest will be in BJT. So see my dear friend, where is BJT? Yeah, BJT is present, but secondary breakdown problem is also present. So for BJT, best thing is 1. Now beta, IGBT is modified version of BJT. So IGBT will provide a small on state drop. So for C, that option will be 3. It is clear? Now what about MOSFET? Large on state drop and slow device. MOSFET is not slow device. MOSFET frequency is highest. So MOSFET is fastest device. I repeat, MOSFET is fastest device. So MOSFET is not slow device. MOSFET introduce large on state drop. Now thyristor is slow device. This is the thing. Now you can match your answer. It is clear to all? So you are saying C. C means that one. So for 4, D means 4. Yeah, D means 4 is this one. Yeah, you can match it. Okay. So no need to like do like further analysis. I think you are capable to understand all those things. It is clear to all? Now, if you have any doubt, please let me know, my dear friend. Otherwise, we are going to discuss next example. Yes, tell me, what is the kind of specific features of BJT are? First, read the question carefully. Thank you. Thank you, Mistry ji. Thank you, yaar. So, yes, tell me, beta ji, BJT features. Just first read the features and tell me. Specific feature of BJT. First, listen to me carefully. Very small on-state resistance. What I told you? BJT offers minimum conduction loss in comparison to any other. Or when conduction loss will be minimum? When, my dear friend, R on is very low. Turn on resistance is very low. So BJT turn on resistance is very low. Please mind it. BJT conduction loss are very low. Just mind it. And that conduction loss is nothing but, my dear friend, current through BJT square into R on. That value should be RMS. So if that loss is very low, it means this R value should be low. So this thing, first statement is right. Very small turn on resistance. Now, presence of second breakdown, we have already discussed. So presence of secondary breakdown, why? Negative temperature coefficient. Negative temperature coefficient. Now see, infinite input resistance. Now everyone tell me, BJT base current is zero or non-zero? Please, everyone. BJT base current is zero or non-zero? Everyone, please tell me fast. BJT base current is zero or non-zero? Yes, boss. Tell me fast. Don't reply answer, dear. Please tell me my question answer. BJT base current is zero or non-zero? Yes, thank you everyone. Non-zero. If BJT base current is non-zero, then input impedance cannot be infinite. What about MOSFET gate current? Yes, thank you everyone. Tell me MOSFET gate current. Now tell me MOSFET gate current is zero or non-zero? MOSFET gate current is zero or non-zero? MOSFET gate current is zero non-zero? Yeah, zero. Please mind it. MOSFET, ध्यान से सुनना बेटा, MOSFET gate current zero. Because what is the full form of MOSFET? Metal oxide. That means there is insulating material in between operating circuit and controlling circuit. See, my dear friend, what is the symbol of MOSFET? Something like this. This circuit is called operating circuit, and that circuit gate 1 is called controlling circuit. There is no relation in between operating and controlling. Why? Because here insulating material. So when gate current is zero, that type of device will provide infinite impedance, input impedance. What about IGBT? IGBT full form is insulated gate. Again, there is insulating material in between gate of IGBT and operating circuit of IGBT. So input current of IGBT, like controlling current, and input current or controlling current of MOSFET, both are zero. Due to that reason, IGBT and MOSFET input resistance or input impedance is kind of infinite, but unfortunately not for BJT. That's why BJT switching loss is high. Even frequency is also one reason. Okay, so here, my dear friend, infinite input impedance resistance something is wrong. Clear to all? Is wrong. Okay, now my dear friend, good performance in parallel operation. IGBT zero, बेहतरीन यार बेटा जी, बहुत अच्छा कर रहे हैं आप लोग. So MOSFET gate current is zero. Definitely, all of you are absolutely right. Okay. So now, my dear friend, good performance in parallel operation. What is the meaning of parallel operation? Just listen to me carefully. My dear friend, if we have some IGBT or BJT, actually our device is BJT, so I'm going to draw here. This is our BJT, and we are going to consider one anti-parallel diode. This is our BJT, anti-parallel diode. Please mind it, my dear friend. When we use that type of configuration, ध्यान देना बेटा, when we use that type of configuration, the diode power loss, okay, power loss of diode are almost zero. This is the beauty of BJT. Please mind it, this is the beauty of BJT. When we use anti-parallel connection of BJT and diode, diode offers almost zero conduction loss. So please mind it, my dear friend, that option, good performance in parallel operation, may be right. Okay, now according to option you have to select. So option third is wrong. Third means this one is wrong, so that is wrong, this one is wrong, and that one is wrong. So only 1 and 2. Please mind it, my dear friend. According to option we are going to dealing our answer, but please mind it that option 4-1 can also be right, but unfortunately we don't have such option, so that's why we cannot take. Okay, so this is the thing. Now I think it is clear to all. Yes, anyone, please tell me what will be our answer, correct answer. Yeah, option D. Obviously everyone, all of you are right. Okay, my dear friend, so I stop my lecture here, and very I'm thankful to all of you, okay, to attend this lecture at Gradeup platform. And tomorrow we will discuss chopper circuit and just few examples related to rectifier as well, and AC voltage regulator. Yeah, definitely Shashank, I will keep that point in my mind. So I will cover definitely tomorrow chopper and just few examples of rectifier and few problems from transient also. Okay, so thank you everyone, and we will meet tomorrow again at the same time. Okay, so thank you everyone, thank you. Yes, tomorrow timing is also same, my dear friend, 5:30. Wonderful class ever. Thank you, Gunti. Thank you. Yeah, continue. Thank you.